Computers don't encrypt passwords. Instead, something more clever occurs. So, when a computer account is created, there is a username and password. The password is the secret that allows the account to be logged in. So, if computers don't encrypt passwords, then how are passwords safely stored? First, a brief description of how encryption works. Okay, encryption is a really large and complex topic. I have no way to fully describe how encryption works in a short YouTube video, so here is the gist of it. Strings of text are represented as numbers. Each character maps to a number. The numbers in long arrays are inserted into equations that convert the number into another number. The algorithm that the equation uses is known as a cipher. The output array of numbers is known as ciphertext, which is the encrypted string. The equation used in the cipher would have special numbers known as keys. The keys, which come in pairs, have special properties that is used to encrypt and decrypt. To decrypt, the encrypted string is inserted into the same equation with a different pair of keys. This decrypts the ciphertext, returning the original string. This, of course, is an extremely simplified view of how encryption works. So, wouldn't this work for passwords? Passwords are generally not encrypted because of the keys. The keys used in encryption have to be stored somewhere. If the keys are leaked, then the password can be decrypted. Securing the keys might be too much of a hassle, so simpler techniques are used. So, generally, this is how passwords are stored. Passwords are not encrypted, rather they are hashed. A hash is a function that when a string is inserted, produces a hash string. The output hash is a representation of the input string. The same input string produces the same output hash. Hash functions produce a unique output hash string for every unique input string. There are no ways to convert a hash string back into the input string. If this was possible, then the hash function is deprecated and not used anymore. Now, there is such a thing as collision, but for this video, I'm going to ignore collisions as it is quite a complex topic. The computer doesn't actually store the password at all. Instead, it stores the hash of the password. The concept is, when the account is created, the username is stored together with the hash of the password. When the user logs in, any text keyed into the password box is then hashed and compared with the stored hash on the hard disk. If the strings match, then it must be the same password and the password is accepted. If all the parameters to avoid collision is taken into account and the strings are a perfect match, then the user must have entered the correct password and access is allowed. This scheme underpins nearly every password system in the world. In certain operating systems, you are even allowed to look at the content of the password file without any issues, because it isn't actually passwords in there, it's just hashes of passwords. This is a commonly used scheme, but there are some issues with this scheme. A person could try to guess the password. Brute forcing is a technique to generate hashes for all combination of strings. If a hash generated from a brute force matches a hash in a password file, then the password is guessed. This technique of brute forcing can be made quicker using tables known as rainbow tables. These rainbow tables are the key reason you should not use common words for your password. Hash functions do have a defense against this brute forcing even when using rainbow tables. A random string known as a salt is added to the input string when the hash is generated. The salt is stored in a safe location separate from the hash passwords. The salt is unique per login, so even if two logins have the same password, they would not have the same salt and thus not have the same hash. Well, that's a brief description of hash functions and how passwords are stored in a computer. Passwords generally are better suited to be stored as a hash compared to being encrypted. I will put links to the concepts in this video in the description below. Drop a comment, like, and subscribe. This lets me know what kind of content to produce. Until next time, I'm High Voice, signing out.